Module 7, Basic AutoCAD. Hi, Joe Cerrone. Today I'm going to go through Module 7, which is about dimensioning mechanical and architectural parts. And so we have these different drawings. Um, and then the chapters that they relate to from the AutoCAD and its application textbook would be chapter 16, 17, and 18. And basically we're going to go through dimension styles and standards, as well as linear, radial, and ordinal dimensioning techniques. So as we look at this, what we're looking at is um, being able to set up a dimension standard. Okay, and so when we draw something with AutoCAD, we create the model, or we create the part in model space, and then we will go through and on a dimension layer we'll create these different dimensions. And so in this exercise, if we come back here and we look at AutoCAD, we have this mechanical part right here. And if we go and click on this link, it'll take us to module 7 from my website server. And it's a little bit dated, but the techniques and the format is still the same. If we're to take a look at it, what we're going to do is look at dimensioning a mechanical part. So in the AutoCAD website, we have some helpful things. We have a PowerPoint presentation, which you can click on and download. And this PowerPoint goes through everything you wanted to know about dimensioning. And we'll look at this as we go through. We'll kind of tie the whole thing together in a nice package. And so as we look at the dimensioning in the textbook, AutoCAD and its applications will give us the big picture of how to use dimension styles, and then in this PowerPoint we'll go through things like dimension terminology, associative and non-associative dimensioning, kind of the nuts and bolts of it in a fashion that will tie back into the drawing. So let's get started. If we go to the AutoCAD website and we click on this Student P7 student drawing, you can download that and then you can open it in your AutoCAD and you'll have a part that basically looks like this. And we'll kind of tie that in as we go through and look at these dimensioning exercises. If we come back here to our textbook, what we're looking at is baseline dimensions, horizontal dimensions, unidirectional dimensioning. These are basically techniques. It's basically a company will adopt this format saying we want all the letters and numbers horizontal. Okay, it's a small thing, but instead of having the numbers turned sideways or aligned, that's a dimensioning style. And then once you set up, or as you go through and set up these different dimensioning styles, there will be different formats for that. Size and location dimensions. So here's an example of an architectural dimension, and the style is a little bit different. You'll notice that it's in feet and inches versus in decimal units like imperial inches or millimeters. You'll notice that it uses an architectural tick at the extension line terminator. The dimensions are created from the center line of the windows and doors. Here's a mechanical part with a diameter symbol and then this 1.5-inch dimension. Location dimensions, showing how to locate things like holes to be drilled with a center mark. Center marks are used to locate the center of a radial dimension. Architectural. So it does a decent job of just explaining how to dimension these different features or different aspects. And as we go through, we'll look at how to set up these different dimension styles. And so here's another example of an architectural style, and we have our drawings set up within the title block. So on this example of a floor plan of a bathroom, it's meant to communicate a dimension style which has the correct dimension scale set. And so when we open up an architectural title block, and so if we go here to AutoCAD and I go to module 2, and these are also in D2L, and I download an architectural title block, and I'm not sure if it will open directly, so I'm going to open it from my application. So here's an architectural title block, and then if we were to do our work in model space, and I were to draw a floor plan of 20 by 20 feet, just as a reminder, we would come into this little arrow down here, show the menu bar. We're working in drafting and annotation, which is basically like working with the pencil, drafting. And annotation means text or documenting. And if we were to go to drafting settings, if you still like to use the grid, I would set that up. And see how small that is for an architectural drawing? I would set up a grid of 12 inches and a snap of 6 inches. So if I enable those, and then if I wanted to draw a basic floor plan, as we track this out, we could go, say, 15 feet by 15 feet. And then when we put the dimensions on using an architectural title block, you're going to want to use endpoints because it's very precise. You don't want it to say 15 or 14 inches and 9/16. You want it to be exact. And you'll notice that in the dimension style for architectural drawings, if you go and you click on this little arrow, it'll take you to the dimension style, or I like to teach the commands DDIM. That way you can always find it. And so this is an architectural style, and if we look at it by clicking on the Modify tablet, we can see, and we usually look at these from left to right. So we'll have lines, symbols, and arrows, and so text, fit, primary units, alternate units, and tolerances. And if we take them from left to right, we can basically look at it. This page, there's not a real great deal of information. We'll tie that back to the textbook. Symbols and arrows, though, this is our arrow symbol. So if I wanted to change that to a dot, then I would have a dot type dimension style. And so DDIM, and we'll go back to architectural ticks. And there's a lot of information in here. It takes a little while to kind of get used to it. The textbook does a great job of kind of getting and drilling into it. And so that's why you want to hang on to this comprehensive textbook, because it will give you a place to find this information and to look it up, almost like looking up a word in the dictionary. And then if we click on the layout, click in the viewport, we can then see our dimension and the setup on that. And tying this back together, back to the textbook, if you don't set the dimension scale properly, if you use like a mechanical title block, you won't see the dimension, because essentially this is quite big. It's 10 feet 9¼ inches, and we're representing this part or this floor plan on a piece of paper that's 11 by 17. So everything is scaled, and a lot of times I'll kind of take the reference of taking something with a shrink ray and shrinking it down. Everything is proportionally shrunk down, and so if you don't proportionally shrink or grow the dimensions, which is what dim scale does, then you get a tiny half-inch high piece of text. And think about it, half-inch high piece of text, maybe it's like the size of a Lego. And then what you really need is something that's about 4 inches tall. And so that's how the scale factor comes into play. You blow everything up by a scale factor. And the scale factors for architectural are within units of 12, because there are 12 inches in a foot. So we'll take 12, 24, 48, 96, which will then correlate to our viewport scales. Annotation scale is a way that AutoCAD kind of automatically has a setting that will increase and decrease the size of your text and your dimensions. We're going to just go through one technique for setting dimension, text height, and scale, and that's what they call the manual, where we'll just calculate a dim scale, and we'll also look at viewport scaling. And then if you decide to take this to the second course or the third course, we'll get more into this, because it's kind of complicated for the annotation scale, but the other ones are very straightforward, and it's how most people do it, or how most people will dimension their architectural and mechanical drawings with AutoCAD. So dimension style basically sets up all the settings in this dimension style manager. And so we can create these different dimension styles that we can then apply to our drawings. And so, for example, if we wanted to create a dimension style that would give us inches and metric measurements, we could go back to our drawing, and we'll use the mechanical one this time. And what I can do is I can go into the dimension style manager, and I can modify that, and then the alternate units tab, I can enable alternate units, and it'll provide a scale factor from inches to millimeters, and I can apply that, and I can close it. Now when I put on a dimension, and you want to get the dimensions to the end point, so I kind of had to work that a little bit, and then we want to put those on a dimension layer. Since there isn't one, I'm just going to create one. Typically I'll make those dark green, continuous line type. If you click on these little arrows, if you hover the arrow between the lines and double click, it'll give you the entire title. Continuous line types, and then line weights for dimensions. Old school people would buy a thin lead pencil, a fine 0.3 millimeter HB lead. And so that's an example of how to apply a linear dimension with both inches and millimeters, and we did that by setting up a modification to our dimension style. We could create a new dimension style, and we could call it fractions. And we could set the primary units from decimal to architectural, and it'll be precise up to whatever we set it. Let's set it up to 0.032, and let's disable alternate units, and we can OK that. Now we have two dimension styles. We have our standard, which we could maybe call it dual dimension, and then we have this one I just created called fractions. If I set the fractions one current and I close this, on the annotate tab we should see a dimension style in here that says which one we're using, and I'm still on standard. Nope, I'm wrong. It's over here. Fractions. So it did change it. So it did set it. Okay, and so fractions, standard. So if we use fractions, and then we go to our linear dimension, now we have both a dimension that's a fraction style and a decimal style. And so that's an example of how we can use the dimension manager to manage different types of dimensions and different types of units. So we created a new dimension style. As we look through, what it'll do as you set these different dimension styles is the window will actually update and give you a preview of what you're doing. And so it'll show you how many decimal places, what colors and line types you're using, and line weights. This is kind of the nitty-gritty, but all of your drawings are very standardized, and so they have these international standards organizations that are setting dimensioning styles according to the American National Standards Institute, which will dictate to a certain standard how to dimension mechanical parts. And these are just sort of the small things. Extension lines, so there's just how to calculate the space between these. Most of your CAD managers will set that, like we did for you, in the title block. And so we'll give you a standard dimension style like we have done on the architectural title block and on the B-size mechanical title block. And so I don't think we need to go through every one of these details, but it's a great reference as you start to look into it and you're saying, well, how do I do that dimension style? Hang on to your textbook and go to chapter 16, 17, 18, and 19, and there will be more detail than well, there will be a good amount of detail. It'll be the amount of detail that you need rather than drilling through a bunch of help screens in AutoCAD. I find those aren't really quite as good as the textbooks. Center mark settings, extension lines settings, as we gave an example of how to change a architectural tick to a dot. And then everything is customizable. When we draw with a pencil, this was 3 times as wide as it was high. And we would have to use a ruler and measure things, work with a pencil. Things like DimSen, if you get down to the nitty-gritty of it, when you put a center mark on something, you can set up how much the overhang is or how much this value is. Very precise settings like architectural dimension lengths, arc length dimensions. Things like putting a frame around the text for a basic dimension. And these are some of your different standards and how they're set up. Centered, above. AutoCAD is highly customizable, and that's one of the things people like about it. The Fit tab goes through some things like text placement settings and how to work with the arrows and fine-tuning the placement of the arrowheads and things like that, whether the arrows are like this or if you have a line between them. It's a little bit tricky to work with this. There's not a great deal of content in here on the Fit tab. On the Primary Units tab, we do quite a bit. We'll work with decimal versus architectural. We'll dial in the number of decimal places or the precision. Remember, if you're going to make something that's got this many decimal places, that is very, very precise. So for example, if we go to the third decimal place and you take a piece of paper and you were to measure it, a piece of paper would be about 0.003, and you're going one more decimal place on this, and so you're basically splitting that piece of paper 10 times to be able to get a measurement. And our aerospace companies do that, but these parts, something like this, would become very expensive as you start to work with that. Linear dimensions, we just gave an example on that CAD mechanical print of how to do a linear dimension. We did a linear dimension on the architectural floor plan also, that 15 foot by 15 foot floor plan. Things like zero suppression, angular settings are very fine-tuning. We don't necessarily need to go through those, but displaying alternate units is very common. People who have things manufactured in Europe or South America, anywhere else but the United States, are typically using metric units. And so putting those dimensions on the drawing is a good idea. And then changing the dimension styles, we gave an example of how to use an architectural dimension style or a fractional dimension style. Here's our fractional dimension style, and here's our dual dimension style. And then these are just settings, and so your CAD manager, your teacher, will go through and plug these settings into your title block. And then when I say title block, I mean the dimension style manager of your title block, because you open a drawing and then all the content within that drawing is set. So when we give you a title block, we give you a dimension style and we give you the layers, and so that's a way to standardize that everything looks the same, that the dimension heights are all the same, that they're all the same color. The drawing has black object lines or blue object lines and green dimensions. So if I have 10 different people working on a project, when I assemble the drawings, it looks like they're all on the same page. And we've done that. You set the dimension style current when you have a choice. And that kind of completes this chapter. And then the next chapter goes into a lot of the details on linear and angular dimensions. And we'll take a look at some of those aspects from our PowerPoint. And so as we look at these learning objectives for dimensioning, I'm going to just touch on that for about 5 minutes, and then we're going to wrap this video. And so this is a very good PowerPoint because it goes through all the different terminology on one sheet. And so extension lines, these are your extension lines, this would be the arrow, here's your dimension text. And you might be saying, Joe, put it into the presentation, but I've got a dual monitor and it kind of splits, and so I've got to I'm just going to stick with this because I know it's not going to blow up on me. Associative dimensions means that when you modify the shape of the part, the dimension is modified too. So if I come back here to the CAD drawing and I go and I stretch this window, and I make this room from 15 feet to 18 feet 1 7/8 or 1 1/16, you'll notice that the dimension also modified. That's what's known as an associative dimension, and that's what you want. CAD managers want dimensions to be associative. Sometimes what people will do is they'll get a dimension that's slightly off. They drew it and it's 14 feet 9 inches or 14 feet 11 and 15/16, and so they'll say, okay, for an architectural one that should be fine. But they'll explode the dimension like this, and then if I were to stretch that, then what happens is that the value doesn't change, and it also ruins the associativity. This was supposed to go with it. But you can kind of see the number is still the same. So exploding dimensions, it's going to ruin the integrity of the drawing. You avoid that when possible. It's a way to get other people quite upset with you if they think the dimensions are true and they're not. And so that's what we did. We exploded it, and that changes this dim ASSOC variable. If you type in dim ASSOC, you can turn it off, and then the dimensions will come in one time with the measurement, but then if you change the geometry, the dimensions stay the same. Linear dimensions, okay, that would be a horizontal dimension or a vertical dimension. That's considered linear. Aligned dimensions would be in a dimension that would be along an angle. And so we would want this aligned rather than the horizontal value or the vertical value. Ordinate dimensioning. Ordinate dimensioning is great for manufacturing using CNC programming, because what it allows you to do is have a 0 point and then locate from that 0 point in an X and Y axis the exact location of those holes, which are great for people who are manufacturing parts on CNC machines. Radius dimensioning, diameter dimensioning, they're pretty self-explanatory. Arc length dimensioning, angular dimensions. When you set up the dimension style, you can have it in units of degrees, minutes, and seconds, depending on how precise you want to make your angular dimensions. Baseline dimensioning, just ways of making your dimensions look neat and clean. Adjusting the space between the dimensions, putting in breaks, continuous. Quick dimensions. Quick dimensions are kind of neat. It's got this little lightning bolt. You can just click on 3 or 4 lines and it'll put all of them in at once. Multi-liters. Multi-liters are used to put balloons, be able to call things out. Tolerances are used to put in plus or minus deviation values. If you need something precise, but it doesn't have to be exact, then you have a deviation. Plus 0.002, minus 0.003. Plus a piece of paper or minus a piece of paper thickness as I build that. And that's kind of how it really works, because nothing is perfect like it is in the computer. When you get out, you have things like temperature, you have materials, and that's where GD&T, or geometric dimensioning and tolerancing, comes in, where they'll give even more standards and control points for the size of these parts. And all of your aerospace companies and high precision manufacturers will use GD&T. Center marks, just some ways to set those and the variables that control them. DimCen will set up whether it's a tick or if it's a large center mark. Oblique dimensioning, not really very often used anymore. It's a technique for isometric drawings. And then you can edit the dimensions, but the best way to edit a dimension isn't with these old school commands, it's with grips. And so typically what you'll do is you'll have a drawing, and then if you need to edit it, you click on that dimension and you'll get these blue grips. And then if you click on a blue grip and make it hot, you can move the dimension placement, essentially editing with grips. All right, that completes the dimensioning. We've covered the dimension style manager, and that completes the lecture for dimension styles and basic dimensioning.